The difference between the input and output potential difference of a transformer will depend on the number of windings in each coil. Remember that a transformer is a device that will take an input alternating current and then use the generator effect to induce an output alternating current with a smaller or larger potential difference. The key to this difference is how many windings we have on the secondary coil compared to the primary coil. In this case, since we have more windings on this secondary coil, the output potential difference will be larger than the input potential difference. But in fact, we can take this relation even further. The transformer equation relates the ratio of potential differences in the coils to the ratio of turns in them, where this equation is Vp over Vs is equal to Np over Ns. Here, Vp represents the primary potential difference, the potential difference across the primary coil, and Vs is the secondary PD, the potential difference across the secondary coil. Remember that we measure potential differences like these ones with units of volts. Then Np represents the number of turns in the primary coil, and Ns is the number of turns in the secondary coil. So this equation tells us that the ratio between the potential differences must be the same as the ratio between the coils. You'll need to be able to use this equation, but you don't need to explain how it's derived at GCSE. So let's use this to explain how transformers are designed. First, for a step-up transformer, there will be more turns on the secondary coil than on the primary coil. Remember that we use this type of transformer to increase the size of an input potential difference. Here's an example of a step-up transformer where we have 4 turns on the primary coil and 8 on the secondary coil. So there are less turns on the primary coil. Let's suppose we supply an input alternating current to the primary coil with a potential difference of 5 volts. Since there are more turns on the secondary coil, we'll also have a larger potential difference here. Specifically, as there are twice as many turns on this coil, the potential difference will double to 10 volts. Then, for a step-down transformer, there will be fewer turns on the secondary coil than on the primary coil. Remember that this type of transformer is designed to decrease the potential difference of an alternating current. So here we have 8 turns on the primary coil and 4 on the secondary coil. So there are more turns on the primary coil than the secondary coil. Now let's suppose we provide an input potential difference of 12 volts. This will be greater than the output potential difference from the secondary coil. Specifically, since this coil has half as many turns, this potential difference will be half of 12, so 6 volts. For your exam, you should be able to explain how transformers are designed around this equation, as well as use it for calculations. So let's try an example of this. Car Y wants to buy a transformer for his phone charger, which needs an output potential difference of 46 volts. The input from his house mains is 230 volts, and he can only find transformers with 500 primary coil turns. Calculate the number of turns on the secondary coil of the transformer Car Y needs, and state what type of transformer this is. Now that's quite a lot of information given in this question, but there's actually only a few key details here that we need to work with. So step 1 is to list and label all known and unknown variables, namely what information we have and haven't been given about the coils and potential differences in the transformer. So the primary potential difference is what's being inputted to the transformer. We're told this will be electricity from the mains with a potential difference of 230 volts. Then the secondary potential difference is the output, which will be 46 volts. Then we're told the number of turns on the primary coil is going to be 500, and the turns on the secondary coil is what we need to find out. Next, we need to rearrange the transformer equation for the unknown value, where we'll be starting from the equation Vp over Vs equals Np over Ns, and we need to make Ns the subject. There are a few ways of doing this, but we'll start by multiplying both sides by Ns. This means the fraction on the left-hand side is now being multiplied by Ns, and the Ns in the fraction on the right cancels out, leaving just Np. Then we need to move this fraction to the other side of the equation to leave just Ns on the left. We can do this by multiplying both sides by Vs over Vp, which is just this fraction flipped over. This cancels out the fraction on the left, leaving Ns as needed. And then on the right, we'll have Np multiplied by this fraction. Now we can use this for step 3. Substitute values into the rearranged equation, where we'll be using that Ns is equal to Np times Vs over Vp. So to find the number of turns in the secondary coil, we have to take the number of turns in the primary coil, 500, and multiply it by the secondary potential difference, 46, over the primary potential difference, 230. Putting this into our calculator, we find that there will have to be 100 turns in this coil for the transformer car Y needs. But if we read the question carefully, we also need to state what type of transformer this is. So there's one more step to this problem. So in step 4, compare the input and output potential difference of the transformer to find its type. So we could have actually done this before calculating the turns in the secondary coil. We know that the input potential difference of the transformer was 230 volts, and the secondary potential difference was 46 volts. This means that the primary potential difference was greater than the secondary potential difference. This is the criteria needed for a step-down transformer, though we could have also determined this by comparing the turns in the two coils.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!